Today we're going to be working on word problems that are in a standard form of a line. So you've learned about point-slope form, you've learned about slope-intercept form. The only thing we're going to use the standard form or general form is for these word problems that are coming up. So standard form is ax plus by equal to c. So basically you have your x and your y on the same side and your constant on the other side. Let's take a look at example 1. It says you are in charge of buying apples and oranges for the school picnic. A bag of oranges costs $4 and a bag of apples costs $3. You have $48 to spend. The first thing we have to do is label our variables. So we have to figure out what we're talking about. So we're talking about buying apples and oranges for the picnic. So we know the cost of the oranges, which means we need to know the number of bags that we need to buy. So let's let R equal the number of bags of oranges. And then the other thing we're talking about are apples. So we'll let A equal the number of bags of apples. In letter B, it says to write an equation that models the different amount of apples and oranges that you can buy. If you take a look at number of bags of oranges versus number of bags of apples, this is a case where there's really no independent versus dependent variable. When you get variables that you really don't know which one's independent versus dependent, then you know you have a case where we're going to be using that standard form. So when we write our equation out, our equation is going to look like this. We're going to have a number times one of our variables plus a number times another one of our variables equal to a constant. So if we know that a bag of oranges costs $4 and our variable represents the number of bags, to figure out how much it would cost to buy multiple bags of oranges, we would take 4 times the number of bags. So we would get 4R, and we're going to add that to our apples. So if apples cost us $3, then we can take $3 times the number of bags to find the total cost of the apples. We can add that here, so plus 3A, and that's going to be equal to how much we have to spend, which is $48. Then if we take a look at part C, we need to draw a graph to represent the situation, and we need to label our axes. So again, we don't have a very specific which one's independent versus dependent, so it doesn't really matter which variable you put where. So you could do this as your R-axis and this is A, or you could do this as A and this is R. Again, it doesn't matter which one you choose, you just need to make sure you label your axes. So I'm just going to go ahead and say this is my A-axis, and this is going to be my R-axis. And then what I want to do is I want to graph this. The easiest way to graph this is to use your intercepts. So the first thing I'm going to do is I'm going to find my R-intercept. And if I'm finding an R-intercept, just like our x and y intercepts from before, that means the other variable has to be 0. So here that means that A has to be equal to 0. And if A is 0, we have 4R plus 3 times 0 equal to 48. And remember that 3 times 0 is just 0, so this term is going to cancel out. And we get 4R equal to 48. And if we divide both sides by 4, we get R is equal to 12. Then what we want to do is we want to find the A-intercept. So if we find the A-intercept, that means now R is equal to 0. So we get 4 times 0 plus 3A equal to 48. And then since 4 times 0 is just 0, we're looking at 3A equal to 48. And if we divide both sides by 3, we get A is equal to 16. And then what we need to do is we need to go ahead and graph these. Well, if we take a look at our axes, if we go up by ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I only get to 10, and I need to get to 12 and to 16. So you have to also maybe change how much you go up by. In this case, I could probably just go up by 2s. So this would be 2, 6, 10, 14, and 18. And you can change it on each axis. So if I go up by 2 here, I don't have to go up by 2 here. If you want to, you can. But again, you can have these different. Just again, label which ones you have. But it should work for me to go up by 2s again, going up and down. So I'm going to label this as 2, 4, 6, 8, 10, 12, 14, 16, 18. And then I'm going to go ahead and graph. So our intercept is 12. So on my r-axis, I need to find 12, which is right here. And that's my intercept. And then a is 16. So on my a-axis, I need to get to 16, which is right here. And then I'm going to draw my line through. So that represents all my possibilities. Now if I go to letter D, letter D says, how many bags of apples did you buy if you bought 3 bags of oranges? So it's asking again, how many apples? So A is what I don't know. And then it says, if you buy 3 bags of oranges. So I know R is equal to 3. So I'm going to plug that R into my original equation. So I get 4, and instead of R, I'm plugging in 3 for R, plus 3A equal to 48. So 4 times 3 is 12. So I have 12 plus 3A equal to 48. And then in order to solve, I would need to go ahead and subtract 12 from both sides. And I get 3A equal to 36. And then I can divide both sides by 3. And I get A is equal to 12. So again, the question was how many bags of apples? So I can say 12 bags of apples. Then in the last question here, letter E, it says, what does the intercept on the vertical axis represent? This answer could be different depending on who you are, because it's all going to depend on what you labeled your vertical axis as. So whether you labeled it as R or whether you labeled it as A. So let's go up here and look at that vertical axis. Your vertical axis is the one that goes up and down, which is this axis right here. And we want to know what this represents. Well, first let's think about what ordered pair we have. This is the ordered pair 0, 12. So let's write that down. We have the ordered pair 0, 12. And we want to know what that represents. Well, remember, as we're looking at this, this is A and this was R in our ordered pair, according to the graph that we had. So we can say this represents you can buy 12 bags of oranges if you buy 0 bags of apples. Now remember, if you labeled your axes differently and yours was switched around, you would have to say that you could buy 16 bags of apples if you bought 0 bags of oranges, because you would be looking at the different variables in a different ordered pair right here. So depending on what ordered pair you have here will depend on what you say here. But you must say something about both variables as you write out your sentence. So you can buy 12 bags of oranges if we buy 0 bags of apples. Now after this, you're going to have 3 try this to do, and then check your answers. Each try this has its own separate link, so you can go ahead and do try this number 1, then click on the link to check your answer.